Hello, good morning everyone. My name is Dr. Niyathi, Radiology first year resident from AJ Institute of Medical Sciences and Research Center, Mangalore. I specially thank my guiding professor, Dr. Praveen John Sir from AJ Institute of Medical Sciences. The topic of my paper is Quantifying Pancreatic Elasticity in Type 2 Diabetes using Ultrasound Elastography. Introduction. Type 2 diabetes is associated with the progressive beta cell dysfunction and pancreatic fibrosis. Traditional imaging focuses on morphology, but mechanical properties like elasticity remain underexplored. Ultrasound elastography enables non invasive quantification of tissue stiffness, offering a window into structural changes. Need for study. Pancreatic stiffness may serve as an early marker of fibrosis in type 2 diabetes. Biomechanical assessment can complement functional evaluation of the pancreas. Objectives of the study. Primary objective to quantify pancreatic elasticity in patients with type 2 diabetes using ultrasound elastography. Secondary objective to examine the relationship between pancreatic stiffness and duration of the diabetes and glycemic control, example HbA1c levels. Methodology. Study design, cross-sectional observational study conducted at AJ Institute of Medical Sciences, Mangalore. Study period, July 2025 to December 2025. Participants, inclusion, adults more than 18 years diagnosed with type 2 diabetes. Exclusion, known pancreatic diseases, example pancreatitis, cancer, prior pancreatic surgery, poor ultrasound window. Ultrasound elastography performed using Sonoscape 80. Shear wave elastography SWE used to measure pancreatic elasticity. Measurements taken from head, body, and tail of pancreas. Values recorded in kilopascals. Each region measured 3 times and mean value calculated. Results. Participant characteristics. Age in years, mean plus or minus standard deviation value 53.6 plus or minus 9, gender male 32 and female 18, body mass index 27.1 plus or minus 3.8, duration of type 2 diabetes in years 6.4 plus or minus 4, HbA1c 8.2 plus or minus 1.3, hypertension 21, dyslipidemia 17, smoking status current 12. Results. This table shows pancreatic elasticity in type 2 diabetes patients, where the different regions of pancreas were imaged and mean shear wave elastography value was taken. In the head, the shear wave elastography value is 8.1 and SD is 1.4. Body 7.5 is the shear wave elastography and SD is 1.2. And tail 7.3 SWE and SD is 1.1. Overall mean of in SWE is 7.6 and SD is 1.2. This image shows pancreatic elastography where red indicates increased stiffness. Pancreatic thickness was measured by the region. Pancreatic region, that is head, mean thickness 2.28 and standard deviation 0.31. Body 1.46 and standard deviation 0.24 and tail 1.62 and standard deviation is 0.29. This image shows a 44-year-old male patient with diabetes. The thickness of pancreatic head, body, and tail was 2.03 centimeter, 1.29 centimeter, and 2.16 centimeter, respectively. This table shows the correlation of pancreatic stiffness with duration of diabetes and HbA1c, where the different regions of pancreas were considered, head, body, and tail, and mean SW shear wave elastography value was taken. Pancreatic stiffness shows a positive correlation with both duration of diabetes and glycemic control HbA1c. Stronger correlation were observed with HbA1c suggested metabolic control may influence pancreatic tissue mechanics. Pancreatic stiffness is generally lowest in patients with recent onset diabetes and highest in those with long-standing diabetes. Overall mean SWE demonstrated statistically significant association with both the parameters. Discussion. Our study demonstrates that pancreatic stiffness can be reliably quantified in patients with type 2 diabetes using shear wave elastography. We observed a positive correlation between pancreatic stiffness and both duration of diabetes and HbA1c levels, suggesting that longer disease duration and poorer glycemic control may contribute to structural remodeling or early fibrotic changes in the pancreas. These findings are consistent with prior research indicating that tissue stiffness increases with metabolic stress and may serve as a non-invasive biomarker for pancreatic fibrosis in diabetes. Unlike most global studies, this analysis provides regional shear wave elastography data from an Indian diabetic population, filling an important gap in context-specific evidence. Conclusion. Pancreatic stiffness measured via ultrasound elastography correlates positively with both diabetes, duration, and glycemic control, highlighting its potential as a non-invasive marker of pancreatic remodeling in type 2 diabetes. Quantitative elastography is a feasible and reproducible tool to assess pancreatic stiffness in type 2 diabetes. Higher stiffness is associated with longer diabetes duration and elevated HbA1c. Shear wave elastography may serve as surrogate marker for early pancreatic fibrosis or parenchymal stress. These are my references. Thank you.